Although we are investigating the planets of our solar system, we have also been trying to understand more about our sun. Man has been fascinated by the sun since the beginning of time. In ancient Britain, the Druids built a mysterious monument to it while in Egypt. The sun was worshipped as a deity, and its passage from day to night was sanctified. The Mayans offered sacrifices to the sun. The Aztecs found it represented time. Although there have been many representations of it from paintings to monuments, we still have a long way to go to fully understand its workings. In the early years of man's study of the universe, there were different beliefs as to its role. Some thought it was not the center of the solar system, but that the Earth was. It was Claudius Ptolemaios who devised the first complete system of the universe. He lived in Alexandria around 200 AD and said that the Earth was the center of the universe. The sun and the planets turn around it in circles. Beyond the planets lies the celestial sphere of stars, which also turns around the Earth. We have learnt much since those times. Today we know that the family of planets, asteroids and comets circle the sun. We also know that our star is like a tiny grain of dust in the universe. In fact, there are so many stars we cannot count them all. Our sun is an average-sized star. It has been found that some small stars do not travel in the company of other stars. And our sun is one of these. Astronomers are able to study the sun in great detail to try and get a better understanding of its structure and energy. It is almost like a vast laboratory. The sun can be studied using a spectroscope. The dark lines that cut across the spectrum band are produced by the radiation from the sun's interior shining through its atmosphere. Each line is the signature of a chemical element such as sodium, iron and calcium. It is this array of lines that forms the code which describes the properties and motion of a star. By narrowing the view of the sun to a single line of the spectrum, each level of the solar atmosphere can be photographed. By using computer mapping and color processing, it is possible to distinguish the levels of brightness. In this way, a detailed and multi-dimensional picture is obtained of the sun undergoing dramatic and turbulent change. The sun is a sphere of hot, seething gases and surges of radiation. Most of the lines we get from the sun comes from a thin, bright layer which defines its visible edge, the photosphere. Above it, the chromosphere, a region of flaming outbursts of gas, extends through a transition zone to the thin outer atmosphere of the corona. Deep beneath the sun's atmospheric shell is the core, a violent nuclear furnace. Here, hydrogen is fused into helium, and in the process, some of the matter is converted into an enormous amount of energy. Radiating outward as a gas, it behaves like a boiling liquid beneath the surface. The turbulent, bubbling motion is visible in the granular cells of the photosphere. Sunspots, regions of intense magnetic fields, appear on the surface. They disappear in a few hours or grow and persist for months in a mysterious 11-year cycle. The sun rotates once every 27 days. Because its equatorial regions rotate faster than the polar caps, the shearing action in the gas contorts the magnetic field into tangled structures which give rise to the sun's eruptive action. The dark areas across the solar disk are coronal holes, which may provide new clues to the sun's interior and may be a source of the solar wind which blows outwards to the farthest planets. On Earth, the effects of these solar events are visible when auroras light up the dark Arctic sky and radio communication is disrupted. The Sun is an average middle-aged star, yet it will generate heat and light for billions of years to come. as it has for 5 billion years past. It dominates the motion of all bodies in the solar system.